Show that a continuous uniform distribution defined on the interval AB has the expectation of x equal to a plus b over 2 and the standard deviation of x equal to b minus a over 2 root 3. So if we have a picture of our distribution, so this is x and this is f of x, then it's going to be 0 along here, and then it's going to get to some value a and be non-zero until it gets to b, and then it will be 0 again, like so. Since the width here is b minus a, the height here will be 1 over b minus a, so that the area is 1. Now, because this is symmetric, for this to be b plus a over 2 is fairly obvious. It's going to be in the middle, and the midpoint of a and b is b plus a over 2. But let's show that it works by integration as well. So remember, the expectation of x is going to be the integral of x, f of x dx for all values of x. So the non-zero values of x are a to b. So the expectation of x is going to be the integral from a to b of x times f of x, which is going to be 1 over b minus a. So that gives us x over b minus a dx. So that's going to be x squared over twice b minus a to be evaluated from a to b. Using the top limit, that's b squared over twice b minus a. And using the bottom limit, that's a squared over twice b minus a. So we have b squared minus a squared over 2b minus a. Now the top is a difference of squares, so we can factorize that to b minus a, b plus a over 2b minus a, and then these cancel, giving us b plus a, or a plus b, over 2. So we've shown that. Now, for the standard deviation, we're going to need the variance. And for the variance, we need the expectation of x squared. And that's going to be the integral of x squared times f of x, so x squared over b minus a dx. And that's going to give us x cubed over 3b minus a to be evaluated from a to b. So that's going to be b cubed over 3b minus a. Take away a cubed over 3b minus a, which is b cubed minus a cubed over 3b minus a. Now there's an identity that you might not know, but it's handy in this situation, a difference of cubes like this. You can factorize that into b minus a, b squared plus ab plus a squared. If you want to, expand that out and check that it works. And so that's 3b minus a on the bottom, and of course the b minus a's cancel. And so the expectation of x squared is b squared plus ab plus a squared over 3. Now, we know that the variance of x is the expectation of x squared take away the expectation of x squared. So that's going to be b squared plus ab plus a squared over 3. Take away, this was the expectation, so that's going to be a plus b over 2 all squared. So that's b squared plus ab plus a squared over 3. Take away a squared plus 2ab plus b squared over 4. Now for 3 and 4 we would have a common denominator of 12. We'll have multiplied the bottom of this by 4, and therefore we need to multiply the top of that by 4. And we'll have multiplied the bottom of this by 3, so we need to multiply the top by 3. And if we do that, then we get 4b squared plus 4ab plus 4a squared minus 3a squared minus 6ab minus 3b squared. And if we tidy that, that gives us b squared minus 2ab plus a squared over 12. And that is b minus a squared over 12. And that's the variance. The standard deviation we know is the square root of the variance. So that's going to be b minus a over root 12. And of course, root 12 is root 4 root 3, which gives us b minus a over 2 root 3 as required.